Welcome back, everyone. So, this is our second part of modern periodic table. Today I'm going to teach you how to find out the variations in periodic table. For example, for Valency, Valence Electrons, metallic characters, electronegativity. How does it vary in a periodic table? So here you can see a little bit rough sketch of a periodic table which has been kept. There are 18 groups, as I told you in the last class. This is group 1, this is group 2, here to here is group 3 to 12, 13, 14, 15, 16, 17, 18. Once again repeating, we are only going to talk about the transitional, we are not going to talk about the transitional elements, we are only going to talk about the representative elements here. And we'll see the variation in those representative elements. So to start with, I'll just teach you how you can write in a simple way the different elements in a periodic table. So let's start. This group 1, we'll write down group 1 has got hydrogen in it. Then it goes to helium. So period 1 has got 2 elements, hydrogen and helium. You have to remember this. Period 2, it starts with lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. This is the second period. The third period has got these elements: sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. And finally the fourth period, the two which we need is potassium and calcium. After that it goes in the transitional elements. So as I have told you in the last class, we have found that period 1 has only 2 elements. So these are the 2 elements. There are no transition elements, there is no other kind of elements in any other group except for this. What about the period 2 and 3? Here also the transition elements are not present. So just rub off this. But when it comes to period 4, it has got 18 elements. So there the transition elements comes. The transition elements, if you see, it will start from scandium and it will go up to zinc. That is in period 12. So anyway, we are not bothered about those transition elements. What we need are basically these particular elements, and then based on it, we're going to explain the variation in their properties. So hydrogen, what is the atomic number of hydrogen? The atomic number of hydrogen is 1. Helium 2, lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, neon is 10. This is 11, magnesium 12, 13, this is 14, 15, 16, 17, 18. This is 19, this is 20. Next, what we need is the electronic configuration of this. So hydrogen, if you write down the configuration of this, 1. We know the KLM shell, this is 1. What about helium? It is 2. Lithium, the electronic configuration will be 2, 1, which you have studied in class 9. Beryllium 2, 2, boron 2, 3, carbon 2, 4, nitrogen 2, 5, oxygen 2, 6, 2, 7, 2, 8. This will be 2, 8, 1, 2, 8, 2, 2, 8, 3, 2, 8, 4, 2, 8, 5, 2, 8, 6, 2, 8, 7, 2, 8, 8. This will be 2, 8, 8, 1, 2, 8, 8, 2. So basically this is how we write down the electronic configurations. Why we need this? We'll need this just to explain to you how the variation takes place in a periodic table. So to first understand the variation, let's talk about the first property. The first such property will be the valence electrons. So what are the valence electrons? the electrons which are present in the outermost shell. Once again I'm repeating, what are valence electrons? The electrons which are present in the outermost shell. So let's see, for this hydrogen, how many electrons are there in the outermost shell? There's only one. What about lithium? It has got two shells, but the number of valence electrons in the last shell is 1. Sodium, it also has got three shells it has got, but the electrons present in the last shell is 1 again. Potassium, 4 shells, the valence electron is 1. Let's take this particular group 13. You see, the valence electron in this particular group is 3. Aluminium has got again 2 and 3, so the last for the valence electron is 3. So how does valence electron vary in a group first? So you look, let's take group 1. It has got 1 valence electron, lithium also has got 1 valence electron, sodium has got 1 valence electron, potassium has got 1 valence electron. So in a group, there is only 1 valence electron. Take the second one, the group 2, it has got 2, 2, 2. Similarly, you see, all of these, the number of valence electrons in a group remains the same. So if a question is asked, how does valency or valence electrons varies in a group? In a group, it remains the same. Okay, now what about the valence electrons as we move across a period from left to right? From left to right. Let's start with this. Anyway, this leave the first period, it is the shortest. We will not bother to touch the shortest period. Let's take the others. What do you see here? It has got 1 electron in the last shell. It has got 2 electrons in the last shell. This is got 3. This is got 4, 5, 6, 7, 8. So what we actually observe, we actually observe that the valence electron in a period, as you move from left to right, increases by 1. So this becomes 1, 2, 3, 4, 5, 6, 7, 8. So this is all about our valence electrons. Let's talk about the valence. We all know the definition of valency. If you are not sure with it, I'll tell you once more what is valency. Just note it down. Valency is a number of electrons an element loses or gains to complete its outermost shell. For example, if you talk about this period 1, hydrogen has got 1 electron, it needs another 1 electron to be like a noble gas 2. Let's say helium. See, if you look at lithium, if the nearest noble gas, which one? The nearest noble gas is helium. So lithium will want to become like helium. How can it become? By losing that 1 electron. Beryllium, again the nearest noble gas. There are 2 noble gases next to it. One is neon, one is helium. I feel the helium is much nearer to beryllium. So it will try to become like helium by losing out those 2 electrons. So its valency in this case will become 2. What about boron? Boron has got 3 electrons or 3 valence electrons. It also wants to become like that of helium. Nearest here neon and helium. Still helium is much more nearer. So it will lose out those 3 electrons. When it comes to carbon, carbon is exactly in the middle. 4 this side, 4 this side. So it will go for this particular neon. So it is going to gain 4 electrons. So its valency becomes 4. What about nitrogen? Nitrogen has got 5 valence electrons. It needs another 3 to become like neon. So valency is 3 in this case. Oxygen, it has got 6 valence electrons. To become like neon, it needs another 2 valence electrons. So it is, the valency is going to be 2. Fluorine, 2,7. It needs 1 more valence electron to become like neon. So this valency of fluorine will be 1. So if you have to find out the valency of this will be 1. This group will be 2. 13 will be 3. 14 will be 4. 15 will be again 3. Remember? 2, 5. To become like the next nearest noble gases, it needs 3 more electrons. So it's 3. Oxygen, if you see, has got 2, 6. So 2. This has got 1. And this is 0. Because it has got completely filled outermost shell. It doesn't need to lose electrons, nor it needs to gain any electrons. So if you look at the valency, what happens to the valency as we move down a group? Group 1's valency is 1. So it is 1 all throughout. So valency doesn't change as we move down a group. But what happens to the valency as we move across a period. Does it change? Yes, it changes. Group 1's valency is 1. Group 2's valency is 2. Group 13's valency is 3. 14's valency is 4. But when it comes to 15, we go down 3. 16, 2. 17, 1. 18, 0. So what is our valency as we move down a group? It does not change. But as we move across a period, it changes. At first it increases from 1 to 4 and then decreases to 0. At first it increases from 1 to 4 and then decreases to 0. So this is how the valency changes in a period and across a period. Next, our important part is the metallic character. What happens to the metallic character as we move down a group? Metallic character can also be known as electropositive character. So what is metallic character? It is the tendency to donate electrons. Metals has the tendency to lose electrons. Metals are those elements which loses electrons. So which will lose electrons? Let's cross it out. Leave hydrogen. Hydrogen's position in the modern periodic table is still debatable. So we'll leave out hydrogen for a moment. Let's talk about lithium. The electron configuration of lithium is 2, 1. It has got 1 valence electrons. Its valency is also 1. So lithium has a tendency to lose that 1 electron. What about sodium? Sodium has got 2, 8, 1. This is also a metal. It's going to lose that 1 electron. Potassium, it has got 4 shells. Again, it has got 1 valence electron. Now look at the atomic radii. I wrote a space. I just write it down. Let's talk about lithium first. Lithium has got 2 shells, so 1 electron. Sodium has got 1, 2, 3 shells, again 1 electron. Potassium has got 1, 2, 3, 4 shells, it has got 1 electron.